All right, we are having this diagram, and in the diagram below, AD and BD are the tangent to a circle at A and B respectively. So we have these two tangents. And you know that the tangents from one point outside the circle, they are equal in length. So there was really no reason for them to tell us that AD is equal to BD, because we knew it by the theorem that these two lines have to be equal to each other because they are tangent from the same point outside the circle. Now AF is equal to FB. This is AF, which is equal to FB. Then AB is produced to cut line through D, which is parallel to FB at C. AF produced to meet DC at E, and this angle is equal to X. This angle is equal to X. So it is required to find 5 other angles equal to X. So we just need to find those angles with reasons. Now we are having this first angle, and we also have this is the tangent, and this is the chord of the circle. Having this one, this one has to be equal to this one, because this is the angle between the tangent and the chord. It has to be equal to the angle subtended by the very same chord at the alternate segment, which is B2, B1 in this case. So which means we have found the first angle, which is equal to X. We are short of 4, and you remember that we are having this line being equal to this line, which means it gives us these two angles being equal to each other, because this is one of the property of an isosceles triangle, that angles facing equal sides have to be equal to each other as well. So one other thing that is given is that we are having this line. Why these lines are given is to be parallel. Maybe they want us to get some information. Okay, so this angle is equal to that angle because these are corresponding angles. Remember, these are the corresponding angles. These angles are above parallel lines, so they are correspondingly equal to each other because of those lines being parallel to each other. Now, one other thing, we just need to remember, this is the tangent as well. We're given that this is also a tangent. So probably tan chord can also work here, because now what are we having? B2 has to be equal to this angle, A1 here. B2 must be also equal to X, which is just the converse of E tan chord theorem, because now this is the tangent and OFB is the chord of the circle. So there is this angle between the tangent and the chord, and we are having the angle, the circumference that is subtended by this chord FB. So this angle between the tangent and the chord has to be equal to that angle at the circumference of the circle in order for this tan chord to be applicable. Now, what are we having next? We still remember the parallel lines. Once you have these lines, let's just redraw this line. We're having this line and this one and this one. Now you can see that these are the alternate angles. So we also have D1 being equal to X as well. Let me just use this line. D1 is also equal to X. So we have all the angles that are equal to X, so which means 5 of them. This is 1, this is 2, this is 3, this is 4, this is 5. So we have found all of them with reasons, because this one we find it by using tan chord, and this one we found it because the opposite angles that are facing opposite equal sides. Then therefore this one we found it by using corresponding angles. Then therefore we remember that when we are having parallel lines and the transversal line, then therefore there will be alternate angles that are going to be equal to each other, especially when the lines are parallel to each other. Let's come to the second question. Prove that ABED is a cyclic quadrilateral. Where is A? Let me just use the different color. A, B, A, D. A, B, D. So we are having this quadrilateral. We are to prove that it is a cyclic quadrilateral. So how can we go about finding that? The idea is that we have figured out that D1, which is this angle, is equal to this A2. Once these angles are equal to each other, then therefore this is a cyclic quadrilateral. So D1 is equal to X and it is equal to A2. So these angles are equal to each other. Otherwise, if we could find this pair also equal to each other, then therefore that would be a cyclic quadrilateral. Or maybe this pair would be, if they were equal to each other, then therefore that would be a cyclic quadrilateral. Or probably this angle, if it was equal to that one, but unfortunately B3, we don't know what is the size of B3. So now let's get into the next one. We just done with 6.2 because we are able to prove that this is a quadrilateral because D1, which is this angle, is equal to that one. We just proved that. Now let's come to prove that ABE is equal to 3ADE. So ABE, where is A? Let me just rub everything else so that I don't get confused. Yeah. ABE, angle ABE, which is this angle, is equal to 3DAE. 3DAE. DAE. So DAE is this angle, which is A1. So which means what are we having? We did prove that DEAB, which is this quadrilateral, that it is a cyclic quadrilateral. That makes B3 to be equal to this A1 as well. This angle has to be equal to this one. If this is a cyclic quadrilateral, this, what you call, these angles has to be equal to each other, which means we're having A1, we're having B3 here. So if these angles are equal, that is a cyclic quadrilateral. So we did now prove that B3 is also equal to X. Let me write another X now. So there are many X's here. Now we're having that one. So you can see that they wanted us to find what is B3 by asking this question, because now you can see that angle ABE, which is angle ABE, which is this whole angle, is equal to 3x, because this is X, this is X, this is another X. So we have 3x there. And the angle DAE, which is this angle is just equal to X. So really ABE is equal to ADE with DAE, and this is 3. This is just 3, because if DAE is X, then BAE is 3x. So really it multiplies with the ABE multiplies DAE 3 times to find its size. So really this is what we have done. So let's prove that AD, let's just forget about everything else. Let's just prove that AD is equal to BC. AD, where is AD? AD is equal to BC. This is BC. So we just need to prove that AD is equal to BC. How can we prove that? So the idea is that to prove that these two things are equal to each other, we just have to remember that we're having this angle. We're having this angle being equal to X, and we also have angle C, which is also equal to X. So that makes UBD being equal to this angle, because when you are having these two angles equal to each other, which means the sides opposite these equal angles must be equal to each other as well. So we are almost done. So which means UBD is equal to UBC, and we did prove that because these two angles are equal, so they have to face equal sides as well. Now, and in the statement or in the diagram, it was given that UBD is equal to UDA. So if UBD is equal to BC and the very same BD is equal to BA, that means UDA is equal to BC. So this is what we have, and this is exactly that we're proving, that DA, which is this side, is equal to that one. So if they are equal to the same side, DB, both of them, then therefore they have to be equal to each other. Thank you. See you in the next video.